Okay, everybody, so what we did today is a thing called trig identity. So, example, here's a problem that really can be written in a much simpler form. So what we do is we do some work on it, we manipulate, we get an easier answer. Same thing with this one, we do some work on it, we get a much nicer answer. Like this one, we get a problem and it looks pretty messy, we get a much simpler answer. This one here, we do some work on it, we get a much simpler answer. Okay, so how do we get all these? Well, we need some identities. Some of these identities we already know. We know, for instance, and here's our identity sheet. If you don't have this, please get this from me. We know cosecant 1 over sine, secant 1 over cosine, cotangent is 1 over tangent. We know also that tangent is y over x, and on our unit circle, we know that cosine is the x value and sine is the y value. So we rewrite tangent as an identity, sine over cosine. Cotangent, we know from the unit circle, is x over y. Again, we know that x is cosine and y is sine, so we have a new identity for cotangent, okay? We have negative angles. We know the sine of a negative angle is equal to the negative sine of that angle. We know the cosine of a negative angle is just equal to the cosine of the positive angle. And the tangent of a negative angle is equal to the negative tangent angle. These are identities that we're going to need. Pythagorean identities comes from the Pythagorean theorem, okay? We know a squared plus b squared equals c squared. But we also learned x squared plus y squared equals r squared. We learned that in our unit circle. And we know that x is cosine squared. We know that y is sine squared, and we know the radius is 1. So here's our Pythagorean identity. Sine squared plus cosine squared equals 1. And then we looked at different variations of this identity. Same thing with tangent. We have an identity with tangent. 1 plus tangent squared equals secant squared. That's an identity. Pythagorean identity, we rewrote that in 2 other different ways. Same thing with cotangent. We've got an identity with cotangent. We wrote that with 3 different ways, okay? We also have cofunctions. We know sine of 90 minus theta is equal to cosine, and vice versa. Cosine of 90 minus theta is equal to sine. Tangent is the same as cotangent, 90 minus theta, or cotangent minus theta equals to tangent. Cosecant and secant go along with sine and cosine, so you'd have the same identities that you have over here, okay? You need this sheet. And then we have some angle formulas that we'll use more in calculus, double angle formula, and half angle formulas. We'll use these more in calculus. Now, I talked one more thing, and that is the squared. Sine squared really means this. It means take the function and square it. I gave an example. It's really like sine of 30 squared. Sine of 30 is 1/2. Squared 1/4. But if you have the square here, see the difference? See the difference where the square is? The difference is if the square is here, you're squaring the angle. So we say, okay, what's this? It's like a 30 squares, like a 900 degree. Totally different. So the square has to be here to mean sine squared. If the square is here, it means the angle squared, okay? So then we did all of this. We did some identities, okay? Tangent times cosine can be rewritten in a nicer way. Tangent, we learned, was sine of cosine. So I rewrote tangent as sine of cosine, canceled the cosines, much simpler version of this. Okay, example 2, well, I needed to FOIL it first because it looks pretty messy, so I multiply 1 times 1, 1 times sine, negative 1 times sine, negative 1 sine times negative sine times sine is negative sine squared. These 2 cancel, positive sine, negative sine, and then we get this 1 minus sine squared. And then I look, it's a sine squared, I look at my identities, and 1 minus sine squared is cosine squared. So I'm going to rewrite this as a cosine squared, and so then that's my answer. So this expression can be simplified to a much nicer version, okay? Example 3, secant. Well, what is secant? Secant is 1 over cosine. I wrote that. Tangent, we know tangent is sine over cosine, so I rewrote it. What I found, nothing canceled, but I do have a common denominator. They both have a cosine squared. Or I'm sorry, they both have a cosine as a common denominator. So I put them together. 1 minus, well, sine times sine is a sine squared. Okay, sine times sine is sine squared. Notice where I put the square, it goes right there. That's an identity. 1 minus sine squared is a cosine squared, so I rewrote that as a cosine squared. Then I realized that one of these cosines will cancel one of these cosines, so I just get a cosine. So this expression simplifies just down to cosine. Much simpler version of this, okay? On the back side, I had a problem like this. I thought, wait a minute, that looks familiar. Cotangent 90 minus theta Cotangent minus 9 theta is just a tangent. Okay, so I rewrote this as a tangent. We learned earlier that another variation of tangent would be to write tangent sine of cosine. And that works out conveniently because the cosines cancel. And I'm just left a sine, okay? Okay, example 5. Well, this 1 is not with the sine squared. It's just 1 minus this. So, okay, I took care of it. I know it's tangent. Wait. Tangent is sine over cosine, but then it'd have to be sine squared over cosine squared because it's tangent squared. So then I flipped it, right? I flipped it because I got a fraction divided by a fraction. So I got sine squared of a over 1. And I flipped this times cosine squared over sine squared. I notice the sine squares would cancel. So then I'd have a 1 minus cosine squared. And I think that's one of my identities. 1 minus cosine squared is the sine squared. And that's my answer. That's a much easier version. So we did page 321, 1 through 6 all. And that's all I have for the lesson. If you have any questions, please ask me.